by our very own Scott Pegau. And he has been working for the Science Center for how long?
Since 2007, 19 years.
Yeah, so he's got a lot of experience in this area. So we can hear from him today. So let's pass it off to Scott.
And the funny thing is, I'm going to talk about herring, even though my background is physics. So I'm a physical oceanographer, and I'll have my disclaimer about, me talking about fish. I got through this whole presentation and I stopped and I said, all I have is pictures of dead fish. Well, lots of lines. So I started with a video to show, yes, I have seen live fish cruising around as well. And this is from a remotely operated vehicle. And I find it fascinating because of how those fish will just come straight up to the camera. I figured it was a good way to get us started to actually see something living. I want to acknowledge that I work and live on the land that's the ancestral territory of the Yak, Sukpiak and Dena'ina peoples. I recognize the enduring connection that these people have to this land and their stewardship of the land and sea, which has sustained them for generations. I also want to acknowledge that this presentation is what I have taken away from staring at other people's data and pondering discussions with fishermen and other community members. And I definitely thank everyone who has been willing to have a discussion with me, because really I have the joy of, I coordinated the herring and research and monitoring program for many years. And that just meant I got to look at everybody's data when they had to turn in their report. So I got to think about everybody's stuff. Disclaimer, I'm distilling down the work of probably 50 plus other people. There's been a lot of years of work that I've been involved with and many years before that. And these are the views I present are my own. They're definitely may or may not be shared by the people that collected the data or the funding organization. So that disclaimer. This is really a presentation on what it does a physical oceanographer here when the biologist speaks to him. Now, the first thing I had to figure out is just general life cycle. And so I figured I'd start there. Herring spawn, they lay their eggs. Eggs, they kind of are there for about 2 weeks, depending on water temperature, hatch, become larvae. Those float around for a couple months. And then they metamorphose, they get their scales and start to look like real fish. Become juveniles, generally juveniles till age 3 or 4. When they join into the adult, we call it, or I'm going to keep calling it recruitment. So they recruit into the adult spawning stock. And so we'll be taking a look at different parts of this life stage as we go along. I think I stole this from Steve Moffat. And it was a historical commercial harvest. And for me, what's really amazing is when you look at this period of the reduction fishery, they took out 200,000 tons in 40 years. Don't think that we've ever estimated the population since the 1980s to exceed 200,000 tons. And so they stripped it out, and within a few years, they were back to fishing. So, that's always amazed me. One of those things I had to learn was that reduction fishery meant that they were reducing the herring for their oil. It wasn't just, I'm going to kill every fish I can find. That was just an incidental. Yeah. But what it really does show is that the system that's out there can handle a lot more fish than we currently have. It could handle a couple 100,000 tons. And there's questions of, could it handle more in those times because there was a lot less whales, and there wasn't the salmon hatchery. Whales and salmon are quite often associated with issues with reduction. And so it may be that there were a lot more herring because of the lack of whales. Don't know, but I think what it does show is that the ocean can handle a lot more herring in the system than we have. So our recent population, and how we estimate the population is using a Bayesian age-structured analysis model. And I'll go a little bit more into that model. This is the current, the black line is the estimated population. The red line is mile days milked or mile days of spawn. So when they fly their surveys, they're mapping how many miles of spawn they observe and then add up the number of days and miles to get to that. There is a black dotted line kind of well hidden down here, and that is the acoustic estimate of the population size. And you'll see that the mile days milked and the acoustic populations actually track each other really well, which has been, a very nice kind of check, because there's a lot of reasons why mile days milk shouldn't be a great measure of the amount of herring out there, but it seems to work here in Prince William Sound very well. So the ASA model, and we will have the standard modeler's disclaimer. All models are wrong. Some models are useful. And we're definitely going to put this model as some models are wrong, but most of the time useful. So it responds to a number of different data sets, many that haven't been collected, like the egg deposition surveys that were done. They're actually extremely critical because the egg deposition surveys are considered the true population by the modelers. So there's actually only a few points that are in here, and they're tied back into here and down in here, which is what is being used as basically truth. And then it uses the mile days milked. It uses an age structure sample that is being taken. So they look at how old the fish is and combine that kind of information along with the acoustic biomass estimate and everything else to give this estimate. It starts in 1980, and I suspect the reason it starts in 1980 is that was when a lot of surveys got standardized. If you actually think about it, pipeline started what, 1973, money started flowing, you were, oh no, it was 77? Yeah. So the pipeline money started up, a lot of surveys were able to get standardized, and so that's always been kind of the starting point, and that's always been my guess as to the reason why. Thing with the ASA model is it estimates the entire time series each year, so the results change each year, which drives me up the wall. I understand why it does it, but it still drives me up the wall. Because of the limited number of inputs that we have, we don't have those egg deposition surveys that are continuing. It ends up making it so that recruitment and mortality kind of get tied together. And so the model has a hard time figuring out collapses in the population. And so what's happening is here in the 92, 93, there was a large collapse in the population. And so they put a fudge factor in for that year to make it collapse because they have to kill the fish off. I point out 2015 because you see the mile days milk kind of extending and then dropping fairly rapidly. Well, the model has it has a mechanism. We don't have an input that actually will make it drop So, in 2016, 2017, the model just kept projecting the population going out. And over years, it said, no, it really did go down. So it's been dropping this part of the population. Yes, Tori. 94, sound right, Tori?
I remember Carl Becker, I mean, there were people that were on that locally, but it did stop right around that.
Yeah, right around 94. I know that it extended after the collapse, but not by a whole lot. I'm going to show you a lot of times I'm going to be comparing to Sitka. And Sitka's model has some different inputs, so it responds a little bit differently. And so it's always interesting. You have two different kind of models going. They're really very similar, but because Sitka does the age deposition surveys each year, it can decouple mortality and recruitment. So it can do things that the Prince William Sound one can't. But basically what we're looking at is, we had the big collapse here in the early 90s. We ran for a long time at around 20, although you see a recruitment period that occurred in the mid to late 90s that fishery reopened for a little while, but kind of stayed going. Then it dropped. It dropped down where we had been around 20,000 tons down to about 5,000 tons. And then it pops back up here, and I'll go into that. So the collapse, as far as I can tell, is that there's really good proof that when the fish came back in 93, the viral hemorrhagic septicemia disease was very prevalent. And I'll talk a little bit more about that disease. So one of my proud moments as a physical oceanographer who cannot pronounce words over 3 syllables long or remember names is that I can say viral hemorrhagic septicemia. And it only took about 7 years to get me to be able to say that. There's another one that I'm going to try again tonight that it's been 15 plus years and I'm only now starting to be able to pronounce the name. So it really does look like it was caused by a VHS outbreak. I've heard people say, was it already collapsing? The mild-age milk is going down. The odd thing was that the egg deposition was going up while the mild-age milk was going down. And it's always kind of had this really odd effect on the model. And it's really the model's trying to balance those factors out. There's been several attempts to see if find a direct tie to the oil spill. To date, I have not seen one. I've heard the potential for gulping oil that may have weakened the fish, but don't find any type of direct connection. Obviously, I got involved in this much too late, and that kind of information wouldn't have been available. It wasn't collected in the 90s, therefore there's no way to really prove it. Indirect effects, it could be that the oil spill had effect on the lower trophic levels that then stressed the fish a couple of years later. But I just wanted to say we've tried to find mathematically a direct effect, and we have not done that. So, wanted to talk about recovery. So I'm going to, for some of you may remember, in the early or mid 2000s, the EBOS Trustee Council had a pretty big effort to define what herring recovery would look like. And so they came up with the Integrated Herring Restoration Program. There was lots of meetings here, and they agreed that the recovery goals were these three. Spawning biomass has been above 43,000 tons for 6 to 8 metric years. And the 43,000 metric tons was kind of based off of what they thought was occurring in the 70s prior to the big buildup that occurred in the late 70s. They wanted 2 strong recruitments of age 3 fish in those 6 to 8 years, and strong being greater than 220 million fish. And they wanted spawning to occur in 3 or more regions of Prince William Sound. So I use this is what recovery means for the trustee council. You know, for me, recovery requires more recruitment than mortality. More new fish have to arrive than old fish die. You know, like I said, the model doesn't have enough information to separate recruitment and mortality. You know, it estimates mortality and it thinks about 25% of the herring out there die each year. You know, and so there's lots of death. What's plotted here is the recruit to spawner. Black is Prince William Sound, red is Sitka. And so this is how many recruits for each spawner that spawned in a given year came back. And I do this by year class because for me it helps to remember, you know, tie everything to year class because I have observation year, year class. There's like 3 different times that can show up and it gets kind of confusing. And one of the more notable things is the general patterns between here and Sitka are actually pretty similar. And, you know, I'm going to point out a couple others where they diverge. But they talked about these 2 to 3 large year classes, and that's because there are these years that just spike up with large recruitment events. And that really kind of drives the population is these once every few years, a large year class comes in. Sorry, that green line is about what it takes to maintain the population. So if the number is above it, the population will be growing. The numbers below it, the population is going to be shrinking. Mortality. And this is Rich Brenner's photo. I always have to turn it upside down because I know where that pen is relative to the shore. And I like to see the fish eating the whale rather than the whale eating the fish. So mortality, you know, what are the main ones? Predation, disease, a lot of consideration of are we in a predator pit? Basically, we can't produce enough new herring to fill all the predators. And so, you know, that's definitely been one of the big concerns is that we can't recover because we can't fill all the predators up. Disease for me has been very eye-opening, mostly because it can kill things fast. And so you can really increase your natural mortality fairly quickly. The other thing that's I've been taking away from this is that, you know, this mortality, the death is fairly localized. When you're looking at Sitka to Prince William Sound, you know, what the mortality factor in Sitka and what's happening in Prince William Sound are not coupled together, you know. And if you're talking to the whale people, yeah, the Prince William Sound whales have learned to eat herring, whereas Sitka whales don't tend to eat herring, you know, to the same degree and things like that. And you know, a disease outbreak is not going to be spreading up and down the coast. So I always think of it as fairly localized. As far as predation, everything seems to like to eat herring. They don't have to be smoked. It's not just the roe, the whales do it, the salmon do it, birds do it. At some life stage, everything seems to want to eat herring. And I like to argue with the whale guys all the time, about are the whales the problem or not? And, it's that argument of, is it a few big mouths or a lot of small mouths? The estimates of predation just on whale energetics is that they would take 20 to 75% of the population. And like I said, the model estimates that the annual mortality is 25%. And so that would mean that the whales take, at their low end, the whales take almost all that loss. And so I like arguing with the whale guys and about theirs. One of the interesting things that's going on is that 2015-16 heat wave, it reduced a lot of predator population. So we are now in the natural experiment of what happens when you really reduce the number of predators. And do we see the rebounds that, would indicate that, yes, we were in a predator pit.
Scott, what species would you put in the predator group? Affected by that.
So with the adult population, it's whales, sea lions. There's a lot of fish. I think the birds, they definitely will take them, but the bigger the fish, the faster they are, the harder they are to catch. And so I always tend to think of birds as younger fish, but I'm looking at Dave because he stares at them a lot more than I do.
Big mouth, little mouth.
Yeah.
Numbers of them.
The bigger you are, the bigger the fish you get to eat. One area that I've been intrigued by and looking at a lot is cannibalism. So if you go into the literature, you'll find that herring like to eat herring. Everybody likes to eat herring. And when you think about it, we have this 4-year cycle that shows up occasionally in recruitment. And it's what in the world happens every 4 years. You go through all the oceanography, nothing's on a 4-year schedule. But the herring the young herring will stay in the nursery area till about age 3 or 4. So they're there for 3 years. So when you have this new year class trying to come into the nursery area, you have 3 older siblings that are all going to try to eat you. And so if you look at it as a kind of a nursery fullness, it would suggest that, if you fill the nursery, then there's so many herring mouths available that they would keep eating the youngsters until those 3-year classes all recruit out. So, what the black line is how full is the nursery, and then when it drops down, then all of a sudden there's space in the nursery and you can get new herring moving in. So it's something that I've been taking a look at because it would explain a 4-year cycle if you use the natural history of the herring rather than just trying to look at the oceanographic conditions. I think it has a lot of explanatory. Disease. So 3 main diseases. I actually knew how to pronounce Ichthyophonus when I started because I had an aquarium. So I knew what it was. Well, I didn't really know what it was, but it's one of those that it's a parasite that you would swear a middle school boy dreamed up because it has a gazillion forms. It can morph into all kinds of different things. And I know Paul Hirschberger was one of the people on here, and he's probably cringing as I explain disease. But there's some really odd questions. A, how is it transmitted? We know that these fish seem to get exposed to it every year, And then most times they build a cyst around that parasite, kind of isolate it. So, the amount of ick in the fish increases as they grow older. But how are they exposed to it? It's not it's not one of those diseases where it can just be in the water. And then when does it become lethal? You can have some pretty sick fish out there that are swimming. And it's okay, at what point does this become a lethal disease? So those are some of the questions I have. Now, here's the one that I've been trying for a gazillion years, VEN, viral erythrocytic necrosis. Okay, biologist, did I come close with the erythrocyte? I always have to remember. It's a really fancy way of saying the red blood cells are being killed. And so the fish down here has the VEN. You can see it does, its gills doesn't show that red color of the red blood cells. And it's one that, we know it's out there. I have not learned much about that disease, probably because I have been more interested in that viral hemorrhagic septicemia, just because there's a lot of literature on it. It's pretty interesting. And for the model, the ASA model, when I said it can kill fish, it uses prevalence. So every year coming up, they'll go out, they will check for disease in a sample of fish. And they will see how many of those fish have VHS, VN, and Ichthyophonus. They check, on 1 or 2 days, certain number of fish, how many are sick right then. A lot of these diseases can come and go quickly. So it's like saying, I will check with the people in this room today, how many people have the flu, and use that to predict how many people had the flu this past year. And so there was quite a bit of the work was to try to get away from prevalence, particularly with VHS, to look at antibody presence and other markers that would say, okay, even though it wasn't sick that day, we can tell it was sick sometime in the last year. So VHS, super infectious. It's amazing how little it takes to, at least to me, to get fish sick with this disease. And it can have a very high mortality rate. Older it is, the higher the mortality rate. They can be 80 to 90% at the top end. Or, if the fish is exposed, that's a chance that it'll die. The good thing is, once you've had it, you become refractory. You become immune to having it again later in life. The bad thing is, it seems like that the viruses can stay with that fish, and that fish can shed viruses much later in life. So you end up having some fish out there that they don't have the symptoms, but they're shedding some virus particles, so they can always expose others.
Scott, what's that vertical axis? Sorry, is that parts per million or something?
It is PFUI. It's some number of units, viral units per mil. And, this scale is 0 to 700. I believe that Paul has told me he's been able to expose a fish at under 1 and get an outbreak to occur. And we're talking the 700 in this graph. And what this graph is, so one of the ways that when they do the disease work is they can find the fish, give them a week, and that will light the disease off. And so this data is actually from a closed pound. And it's the viral load in that closed pound. And like I said, it takes like 1 to light off an epidemic. And within that pound in 7 days, they're at 700. And it's starting to show up outside the pound in the surrounding waters that the viral loads have gotten that high. When you look at what's happening is about 7 days in a closed pound, the fish are still alive, but they are super sick. You open that pound up, you are injecting a lot of very diseased fish into the population. And so this is why I always, I saw today's announcement about, the herring, and I quickly scrolled down to see the closed pound, because I'm definitely one that I would want to avoid closed pounds, because that's how we kind of spread that disease when we want to do it experimentally. Oh, and I meant to show, this is kind of, you see the blood coming out around the face, eyes, and along the fins. It's kind of the signs of VHS. So VHS is definitely associated with the 92, 93 population drop. I've often looked, here's 2015, here's the seropositive. So it's how many of those fish have antibodies in them. And so you can see that between 2014 and 2015, there's a big spike up in the presence of antibodies, which would suggest that the population between 2014 and 2015 had a large outbreak of VHS. Like I said, it can be really lethal. And at the same time, we have this modern drop here at 2015 in the population. And so I think it's quite likely that VHS was the cause of that 2015 drop as well. In 2019, you see the disease drops quite a bit. And what happened was there was a huge year class. The 2016 year class starts to join the spawning population in 2019. Those fish had never been exposed to the disease. And so when you go to take a sample, you have all of these zeros now that are just joined the population. So it really dropped the amount of fish out there that are carrying the antibodies. Good and bad. Go ahead.
What's the number at the top of the bar?
The number of fish samples.
Okay.
The good part is the disease is not as prevalent throughout the population. The bad news is there's a lot of naive fish that could get the disease. And so the good and bad of it. There's also been a lot of other things trying to take a look at the effects of mortality. So using the model, throwing in a lot of other factors, again, another one of those, correlation is not causation. You have to be careful. The one factor that kind of is very weakly related is total pink salmon return. But it's a very weak relationship, and they're continuing to work. So I'm going to kind of keep moving from mortality recruitment. The earlier the life stage, the greater the mortality. You're gonna, a female will lay around 20,000 eggs, and we're hoping to get one recruit out of that 20,000 eggs. And and that means surviving to age 3. And so quite likely our recruitment strength is in this early life stages within the first year. Again, looking at Prince William Sound and Sitka recruitment, you see throughout the Gulf of Alaska, the recruitment tends to be fairly synchronized, at least on the outside populations. When you talk southeast inside populations, there's lots of good reasons for them to go out of sync. The big things that jump out at me are this separation right after the collapse. And it may be that the disease was continuing to kill the younger fish that as they tried to join the spawning stock, that spawning stock just had so much disease and shedding that it was continuing to limit recruitment through that time period. Then we had a large recruitment event, 99 or 2000, and things seemed to lock in. 2012, for some reason, no recruitment in Prince William Sound, great recruitment everywhere else. 2016 comes around and it just has this, astonishing amount of recruitment, and it's throughout the area. And I've spent a lot of time trying to figure out what's driving this, and it's really a lot of stars have to align, and so you're looking at a lot of different things, and there's no one thing that's going to really drive good recruitment. We looked at a little bit at nursery fullness, at cannibalism aspect. I think that comes into play, but there's a lot of other things. So some of the things looked at: early growth. You remember, the earlier it is, the more things are likely to kill it. So looking particularly at that larval stage, they have about a week. They have enough of a egg yolk that they carry, in the as after they've hatched, to last about a week, and they have to start feeding in that week. So looking at both the quality and the quantity of food, where diatoms may have some essential fatty acids that those fish need to grow. But also thinking, what our small zooplankton are. And so in this plot, small zooplankton are the circles, and the dotted line is the total zooplankton biomass out there. So it's not only how much food is out there, but is it the right size? You've got these little larvae with tiny mouths. They have to eat small things. And so and you look, you had the strong recruitment right here around 2000. You have a strong recruitment here at 2016. 2012, it wasn't that great for the small diatoms or small zooplankton, but at least Sitka and Kodiak had good recruitment. Another thing, early growth, faster you grow, the fewer things can eat you. So that's really beneficial to grow fast. So this is actually the length of age 0 herring, so this is in August. How long are the herring that were laid that year? And it comes from bird diets out at Middleton Island. And you can see in 2016, those fish by August were large compared to the other years. And 2015, 2016, we had the heat wave. So you had heat, and when a fish is warm, its metabolism is up, so it can grow faster. It can go through more food. One of the other things that we learned is that those fish have to reach a certain length before they stop growing for length and start putting on fat. And putting on fat is real important to make it through the winter. But one of the things we saw was that 2016 fish weren't really all that remarkably fat in the fall. We've looked at early growth from scales, and we don't find a relationship between the growth and the recruitment. But as I just said, what happens is that they grow, they stop growing and start putting on fat. The scales are telling us the total story of the first year, not that early part, and that may be what's really kind of driving the relationship. spend a lot of time looking at overwintering energetics. And basically, this is a time series from Simpson Bay where we started catching fish, and this is lipid, how much fat was in those fish going in. You see it really kind of build up, and then it just drops back away as the fish aren't finding food through the winter. And by March, that red line is these fish should be dead kind of line. And so they are right at the limits of survival, at least in the years that we were looking. And then once they start feeding, you see them start to grow really well. And it could be that the survivors, which to us are the important ones, are ones that somehow manage to continue to eat and grow through the winter. And there's some evidence in the scales. Quite often, they'll have a hard time finding that first annuli. You don't get a nice clear annuli, which would suggest that the fish didn't really slow down its growth nearly as much. And so they were able to keep going. And those are the ones that survived. Looking at the overwintering energetics for several years, we see what's happening in the fall. Doesn't really tell us much about what's going to happen in the spring. The 2012, 2013 is the one remarkable one in this. That's that 2012 year class that keeps driving me up the wall, but keep looking at it. Now that time has come, we've learned that most of this time period was a really low recruitment time period. So we stopped in 2016, in the fall of 2016. So we don't know how they came out in the spring, but we know the 2012 year class seemed to come out of winter really unusually healthy. 2010 was extremely bad. And like I say, 2012 is really good, and so when I was starting to look at food things, 2010 looks better than 2012, but the fish, the fat in them says 2012 was much better than 2010. Learning about juvenile movement, the young, the smallest, the age zeros, using fatty acids as markers of their movement. And so their fatty acids depend on what they eat, and what they eat in each bay can be different. And those fish aren't moving. We don't see those young fish moving from bay to bay through a winter. The older work says, basically what happens is the youngest fish tend to be shallowest and furthest in the bay, and then as time goes on, they'll go deeper and further out. And see it somewhat in aerial surveys. You'll see the schools moving out during the summer. We do know that we'll catch ages 1 through 3 in those nursery areas. So we know that all the year classes are there. When they join the spawning schools, when those age 3, age 4s join the spawning school, that's kind of a totally unknown mechanism. For juveniles, we use acoustic and aerial surveys. This is the aerial surveys saying how many schools did we see as we surveyed Prince William Sound. This is that, this is a flight year instead of year class, which is my mistake. That's the 2012 year class. It looked like it was going to be a great year class in Prince William Sound. I was quite happy. This is like one of 3 markers that all suggested 2012 year class was going to be big. It was going to increase the population in Prince William Sound. We were going to get to see a big recruitment event. But that year class never showed up. It's driving me up the wall. There's a lot of things I know about it, except I don't know how it disappeared. 2016 year class, again, this was a huge year class. 21 actually is a little bit of a reflection of the, as this year class came in, then there's a big spawn event, and you start getting more. 25 survey suggests the 24-year class may also be another big year class. So we may have another one that's coming in. It would be 27 is when that one should show up. So it won't be this year, but next year, hopefully we will see a big push of young fish coming into the system. Those juvenile surveys, we also take a look at it to figure out how distributions change. One of the big questions was retention. Are certain wind conditions more favorable for retention? And the basic circulation pattern looks like this through Prince William Sound. So you have your spawning here on the east side, then it tends to get carried and then brought down through Night Island Passage, and you'll see a lot of fish retained over there. I threw the 2020 year class because it looks like we probably had winds coming in from the southeast, and things got pushed further up in. So as those larvae were drifting, they got pushed further in, and so they recruited more towards the northern side and less being retained down below. 2016 year class, I've definitely been spending a lot of time. It looks like it had great food. It was the right size, the right amount, lots of very small zooplankton available. Had warm water, which is great for growth. It was doing well. Predation, the predators hadn't all died yet, but is that one of the things? The winds seem to be favoring, retention, and then but the overwintering energetics is one where we don't know that answer. We stopped doing those measurements before that happened, and it's one of those things that two hardest things to do is start a time series and end a time series. And it was one where it's okay, what can you tell me from this time series? And if the answer is we just need to keep measuring, and it's, well, you need to tell me something at some point. And the decision was made to focus elsewhere rather than just continuing to make measurements. Unfortunately, we stopped it half a year too early. My fault, I'll admit it. So a lot of other research going on. Some of the monitoring, so we talked about the spawn surveys in, that's mild state melt is MDM. Look at their age structure, look at their condition. So like here we have weighted age, and you can see time periods where particularly when the older adults really start losing weight, conditions have to be bad in the ocean, because the older the adult is, the more it's going to put into egg production and be willing to sacrifice its own body for that. So you can see that there was a nutritional stress that it was occurring in the early 1990s. That was just prior to the disease. Here in 2015, so many of the older fish died that here the age 7 and 8, we don't have enough fish to have a decent number to provide. So you can see that there's the heat wave led to some real poor condition. We had the disease, a lot of things all went on, and so that really hit that population. You can see that the age 3s and 4s don't have that same thing, and it's partly because we think those fish tend to stay more in Prince William Sound. The older fish tend to move more towards the ocean for summer feeding, and so they're feeding in different areas. They're going to have different food availability, and like I said, the older the fish, the more it's going to be put into its eggs rather than into its body. Younger fish are going, I'm going for health. Looked at spawn movement, and basically the spawn areas expand as the number of fish increase. Every time you get a big recruit class like that 2016 year class as it comes in, all of a sudden you have 3 times as many age 3 fish as you have old fish. All those young fish are going, I'm not following grandma. I'm headed off to new land. We're going elsewhere. And so you start seeing fish spawn in all kinds of different areas. But once they start spawning in an area, they'll tend to go back to that area. But one of the other things that happens is that large year class starts to die off. The areas that they were using may not be used anymore. So you'll see contractions and expansions go with the different year classes. And after the collapse, it kind of dropped down into the Montague, Ravenna area. There was a hypothesis that the move mostly to Ravenna may have been driven by whales. Whales were hammering the spawning stocks off of Ravenna, but there was also that large year class from 1999, and so they may have just, well, we're going to pick a different area and move that spawning area. Genetics. Some of the interesting things, so if you talk Bering Sea, most of the geneticists say that should be a totally different species. It is genetically very, very different. There's a large change around Kodiak Island, which has a physical oceanographer bothers. I know that in 2 months, larvae from Prince William Sound can easily make it into the Kodiak area. But there's a big break at Cook Inlet in the genetics of fish, which has always perplexed me. I just learned, I've always thought Yakutat through Prince William Sound, Kayak Island, they were all the same. And I was just talking to a geneticist that said, oh no, Yakutat is slightly different. It's got there's some herring have a freshwater kind of signal to their genetics. And that the herring in the Yakutat area get spawn in areas that have enough fresh water that they have a different genetic structure. For a while there, we were tagging adults. Using acoustic tags. There's some receivers that are spread around Prince William Sound. We're trying to see what was happening. And boy, once those fish spawn, they're out of here. It takes them like 2 to 3 days to be out Montague Strait. They're looking for food. They're hungry. And so they leave pretty rapidly, many through the southern end of Montague Strait, some out of Hinchinbrook entrance, but quite often those will pop around the corner down at the base of Montague Strait as well. And they start to return from September to February, start trickling back in. And the larger the fish, the more likely it is to leave. It seems like they're, we don't know exactly where they are, but the fact that they drift back and forth across where the receivers are would suggest that a lot of them hang just south of the Montague Strait, or south and west. For me, Jim Aguiar had been telling me for years about herring spawning on his oysters in June. It was June. Herring spawn in April, maybe May, not June. And sure enough, finally we're out there and, oh yeah, they're spawning in June, just like Jim had told me for many years. Simpson Bay. And if you go into the historical literature, they've always found smaller juveniles in Simpson Bay. And it's probably related to the fact that you have all these fish that spawn locally, and those larvae are being retained there. And, but they respond a month later than everybody else. There was a report a couple of years ago from both Pigott Bay and Crab Bay, also spawn in June. And this is one where I'm definitely looking for reports of where do people see evidence of this late spawn, because I'm really trying to get a feel for, what is it? Is this just small local populations? How does this really come into play? And so what's pictured here is in Simpson Bay, and these are those adult fish waiting to spawn. Kayak Island. This one draws a lot of attention. This is one of those, I doubt that I'll ever get to see this nice. All the herring spawned on like 1.5 days at Kayak Island. And it was clear enough that the satellite could get a really good picture. And so it's just amazing how it lights up with all that spawn activity around the island. The thing is, with Kayak Island, the observations have always been sporadic. There is, it's outside the Prince William Sound general population that has been surveyed. We've known that there's fish out there for quite some time. The fishermen coming back from Sitka would always report, seeing the schools of fish, but really haven't put the effort until fairly recently to learn more about that. There was concern that maybe what happened in 2015 was that the fish that would normally recruit into Prince William Sound went to Kayak Island instead. We haven't surveyed regularly using the satellite data and everything else, but I can find is we have evidence that there was about somewhere between 5 and 10 mile days of spawn on Kayak Island until about 2020. 2020 there's a bunch of satellite images that suggest that it had built up to what it is now, around 40 mile days. So it took a huge increase in population. That huge increase from going from, between 5 and 10 to 40 is about the same change that happened in Prince William Sound, about a 5-fold increase as the 2019 or 2016 year class joins. But really gets to me is, okay, Kayak Island, it's out there. Any larvae coming off this island, they're just blown down the coast. This is a dead end population. I've said that for many, many years. And then this spring or winter, somebody had to burst my bubble. And, and it was one of those where I should have figured out is if you can have that much spawn year after year, there has to be a nursery area. I'm just so used to the nursery areas being these embayments. This population seems to be holding its own without using those traditional areas. So if you look at the Middleton Island bird diet, and this is rhinoceros aqua's diet, these birds are eating, I can see them eating H0s, the spawn, as those fish are moving down the coast, the birds are exposed to them, but the dark blue is H1s. And so those juveniles are out there on the shelf all winter long, and so the birds are able to get to them next spring. So there's a big area on the shelf, and this is, they tagged birds. They had geo tags on them, and as bird came back, the bird biologists did their thing, made them spit their catch out. And, this was the furthest that bird had flown. And the blue dots, or the light blue dots, are age 1 herring that they, in this case, kittiwakes, had eaten. So they are finding these young herring all through the middle of the shelf. And so my thought that they would just get blown down the coast is totally wrong. That population can be self-sustaining. The nursery area is not protected bays. It's just sitting right in the middle of the shelf. Great thing about birds, they are a bias sampler. So in a year where there's lots of other prey available real near the island, that's all they ate. But with the diving birds, they seem to do a little bit better for having a good distribution. So some of the mysteries. Biggest mystery is why it's the big recruit year is always a leap year. I don't know why. It's the lies, damn lies, and statistics. It just happens to always seem to fall on the leap year is the good recruitment years. What happened to the 2012 year class? We didn't see it in Prince William Sound. We saw it, at Middleton Island. We saw it at Kodiak. We saw it at Sitka. And there was all these indicators that pointed to a strong year class, at least through H1. Why wasn't it 2010? That one, I think I figured out 2010, they just weren't in good shape. They had better food availability, but something didn't work out. For me, the 1988 year class is really interesting because they would have been 1 year old during the oil spill. So they were small fish and they would have been along the coastal areas. Yet that was one of the strongest year classes. Lots of evidence that eggs and early stage larvae, the exposure to very small amounts of oil causes a lot of harm. So why did when does that degree of harm start to drop off? Because somehow these H1 fish survive very well. We looked at the migration from Prince William Sound to Kayak. I don't think that actually occurred. Why were the juveniles so healthy in the spring of 2013? Don't know. School joining, adult overwintering. There's a lot of things that we've talked about. So, I guess big take home message: why haven't herring recovered? And I think there's 3 things that have occurred that really have limited herring recovery. One is this period of low recruitment in the 90s. If we had been recruiting like Sitka was, that population would have just slowly been building up back up. And that's what Sitka did, is it stayed high, but it continued to build up. So that really kind of limited us for a long time. The next big problem was this drop in 2015 when we went from 20,000 tons to 5,000 tons. And the reason that was really bad is when that 2016 year class came in and it basically multiplied the population by a factor of 4 to 5. We were starting at 5,000, made it up to 25,000 instead of starting at 20,000, going up to 80 to 100,000. And the third is that darn 2012 year class, because if it had recruited in as well, we would have been talking 100,000 tons out there right now. But that 2012 year class didn't show up and we had that big drop. So, to have recovery, we have to have these large recruitment events. We've had one. Unfortunately, there was a big drop in the population just prior to that, and that's what's really kind of limited our recovery. There is, in the restoration plan, looked at active restoration, looked at some of the bottlenecks, trying to figure out what can you do to actually improve the herring stocks. If you talk to someone from out of the area, they always, habitat degradation. Oh, there's lots of habitat. Um, one of the things talked about was moving eggs, and I guess this is happening in Southeast. They're trying to build up a population by moving eggs from Sitka. But I sat down and did the paper work on it. If if you get one adult for every 20,000 eggs, it turned out that you had needed 1 to 2 trillion eggs, or about 1,000 square meters of egg deposition to really actually have enough to move the needle very much at all. We had looked at it in Prince William Sound thinking, oh yeah, if we move the eggs, we could potentially get greater retention. And looking at the distribution of age ones, I don't think that's really the issue. So if you looked at hatcheries, my estimate is it would take about 400 million fat seed zeros. So if you took the eggs and you grew them up until October and released them, you need about 400 million. You need to do that for about 10 years. Or you could keep them through the winter and only need to get about 200 million age one going out, because look, about 50% of the age zeros die each year. But then you have to distribute them. You can't just release them in one area because they're all going to stay there. And there's not enough food to feed that many. So somehow you have to spread them everywhere. So how are you going to distribute in the nurseries? So I don't think active restoration is truly viable. If I was going to do it, I'd be focused up in this area because it is an underutilized part of the sound. Just the way circulation is, most of the time, larvae won't get pushed up into that area. So there's a little bit of room, but not enough to move the needle significantly. So in conclusion, we've learned a lot, but there are a lot of important mysteries left. We're always stuck wanting more information. Somehow we stopped the time series 6 months too early. Something's going to happen. Recruitment appears to be driven by large scale things. We're talking the entire Gulf of Alaska type of things. But mortality tends to be more localized, this top down. The recruit class is likely to be determined within the first year of life, although 2012 is my exception. That keeps driving me up the wall because that appears to have died some time after the first year of life. We need more large recruitment events like the 2016 year class. I've seen a couple strong indicators that the 2024 year class could be very strong. Both our aerial observations, the bird observations, all suggest that was a large age 1 year class. So I'm hopeful for 2027. And I always ask people, share your observation. I learn from everybody as far as whenever you give me an observation, it gets stuck in my little filing cabinet and I will mull on it until I can figure out what to do with it. And I have to thank the Exxon Valdez Oilspill Trustee Council as the primary funding source, not the only, but the primary funding source for this work. And with that, if you want to find more information, look at the Prince William Sound Science Center's website. There's a Facebook page for the Herring Watch where we try to bounce a lot of the Fish and Games information over to make that available. But if you go to the Fish and Game website, they have great spawn maps. They put all their historical stuff in there. It's all that you can just flip from year to year, and it's a really great thing. Alaska Ocean Observing Systems Data Portal and the EVOS Trustee Council website. Thank you for your patience. Goodbye.
You guys don't have to stick around, but if anyone has questions, please feel free to ask. We're not racing out of here.
What's the plasticity in their diet through age classes? Are they have variable diets going on, or have you been able to do any like compound specific isotope analysis to like really look into how maybe food webs change through time?
I have not seen that. There's some isotope work that I know that was done, but I don't think that it's provided that. I know it did carbon and nitrogen, so it probably could have been used, but I haven't looked at it in that manner.
Thank you.
Should ask Paul if I said something really bad with the disease stuff.
No, Scott, I'm going to pipe in here because I think it was a wonderful talk. Thank you. I had a couple of observations that I was going to run by you, if you don't mind. The first was your very first slide. It was the video of the juveniles that were swimming around Simpson Bay. And what struck me about that video was that the fish were very emaciated in that video. And then I was really intrigued to hear you say that later on in your talk that those Simpson Bay fish spawn in June. So presumably they had very little time to grow and put on fat reserves going into that first winter. So coming out of that in March when that video was taken, they would have been emaciated.
Yeah, and it was spring video, so that's definitely survivors that aren't in good shape.
I guess my second comment was I was really intrigued by your cannibalism hypothesis, and I think that we have some observations to support that. Certainly, when the herring are spawning, we'll see adult herring that go through and ram feed on those eggs as they're being deposited, and sometimes we'll see male herring with testes that superficially look like a female because their stomachs are so enlarged and full of eggs that they look like ovaries. So yeah, they do eat a lot of eggs. And the other thing that we see in the lab, at least under food limited conditions in the lab, larvae will start to eat other larvae. So right around metamorphosis, we'll get some larvae the mass is 10 times larger than others. And when they open them up, they've been eating there's other herring larvae in their stomachs.
Cool. Thank you.
Yeah. And the third observation I was going to throw by you, I don't know if you've seen these data yet, and I'm glad Kristen's on the line here too. But gosh, there was probably 4 or 5 years there that you were leading those, you and others were leading those juvenile herring surveys, and we were looking for VEN, and we saw very little VEN in those fish throughout the entire juvenile herring survey period. But this last year, when Kristen and was out on the water and sending us samples, we had really high prevalences of VEN in juvenile herring this year, and I can't quite wrap my head around why. But I wonder if you had any suggestions.
Not a clue.
Okay. Thanks, Scott. Really nice talk.
Thanks.
Very good talk.
Thanks for your patience.
Thank you.
Thanks, Scott.
That's what I did. I think,